Hello and welcome to my YouTube channel. My name is Siobhan Richards. So for today we'll be discussing natural language processing, LLPs. Okay. So what is natural language processing, right? This is some language, natural language plus processing. Okay. So first we have to look at the natural language component. So what makes up a language? And in our prior programming classes, we've seen where we take real world data and we represent it by a programming language as strings, integers, floats, and so on. But with natural language processing, this is more of AI modeling. So the way we move from real world data to desired output, keeping that von Neumann machine in mind, is basically we're taking the language, creating some model, right? And then use that model for whatever purpose we want as the output. So maybe it's a classification task, clustering task, right, and so on. Okay, so what is natural language? This natural language component of the natural language processing. Well, the language is made up of these layers here, okay? So we have the phonetics, the phonology, morphology, syntax, semantics, and pragmatics. Okay, so we already see syntax and semantics in programming language, right? So, but in real world language, we also have that. So for phonetics, we have speech sounds, right? So the smallest like sounds in speech. Okay, phonemes is the smallest unit of a word. Okay, we have morphology, which is words. We have syntax, which are phrases and sentences. We have semantics, which is the meaning of these phrases and sentences. And then we have context. All right. So what is the context of this sentence? Okay. So just remember, language, we have subject-verb agreement, phonics, and so on. Okay. So now we're looking at the processing component. So we looked at natural language. It could be English language, whatever language you use to communicate. So English, German, Italian, whatever language. So just remember, for NLP, the modality here is text. Okay, language, right? Written language, whether it's by writing or by sound. Okay, so usually it's text. Okay. So what's the NLP task here? How do we apply these machine learning and AI to this? Well, you have language modeling, text classification tasks, information extraction, information retrieval. You could create a conversational AI bot. Okay, you could have text summarization, question and answering systems, right? So most frequently asked questions, machine translation, and topic modeling, right? So these are all tasks associated with natural language processing. So we'll use our AI model as well as our deep learning models to do this processing of these text input. Okay, so just recall, this language is the phonology, morphology, syntax, semantics, right? Meaning, pragmatics, context, lexicon, right? So vocab, word classification, discourse, what is the narrative structure? How does each sentence tie together? Orthography, your writing system. Sociolinguistics, right? So for a certain region and for certain social groups, they have their own way of communicating. So language is a very complex system. Okay, so how do we process this complex system? Because some phrase here might not mean exactly what the phrase say, right? It could be a slang, right? So how do we process these different systems here? Okay. And again, so these layers of language, we could use these layers to create our application. So for example, the phonemes, which are speech and sounds, we could move those to speech to text application, speaker identification. So based on some latent detail of these sounds, we could probably identify the speaker, right? Depending on the pitch of the voice and whatever frequency their voice is at. We also could have text-to-speech application from these phonemes. From the morphemes and the lexemes, which are the words, we could have these word embeddings, part of speech tagging, tokenization, syntax, which are phrases. We do parsing, entity extraction, relational extraction. And for context, which is the meaning, we could do summarization, topic modeling, and sentiment analysis. Okay, so these are all the layers that makes up a language, and it's mapped to the application that you could take these data input to these application in computing systems. Okay, so that's the language component. Okay, so let's look at the processing component. For the processing component, we'll add these machine learning algorithms, whether it's machine learning or deep learning. Okay, so for these machine learning, we have unsupervised learning, we could have supervised learning, and we could have reinforcement learning. Okay, so for supervised, we could do some classification. Okay, we could classify the text, right? So we could say, what is the sentiment on this text? Is it a good or bad, right? So it could be a binary classification there on sentiment there. Okay, we could also have unsupervised learning. We could do recommender system based on the body of text. We could recommend maybe some solution to whatever issue is in the text. Okay, and we have reinforcement learning, which is more of like you have this actor and you have the environment, and you keep reinforcing these rewards. Okay, so but typically for NLP, it'll be either supervised or unsupervised. Okay, you could add reinforcement learning if necessary there. Okay, so this is the NLP pipeline. Okay, so we have this data collection, which is the first layer here. So how do we collect this data? Remember, this is language, right? So language could be someone speaking, someone writing, right? So we could collect this data via audio, or it could be a body of text. Okay, the next step is we'll do some cleaning. So how do we clean this data? We could do text cleaning. Okay, so we remove different components of the text that we have somewhat normalized text. Okay, so like unimportant characters, HTML tags, and so on. The next step is pre-processing. Okay, so we'll have our pre-processing there. Feature engineering, so we need this feature vector. Then we need a model, right? So this could be any machine learning or deep learning model. Then we'll do evaluation, deployment, and then monitor. And then maybe our monitoring system will do some update on the data collection as well, provide some feedback there. Okay, so that's the NLP pipeline loop. Okay, so for this red shaded area here, just remember this is the preparing the data, right? If you don't prepare this data right, you'll have bad features, which in turn give you a bad model. So garbage data in or garbage pre-processing procedure gives you a garbage model, right? Just like in coding where you have garbage in, garbage out in terms of the variable. Okay, so here garbage data in, you have a garbage model, right? So these three steps here, from text cleaning all the way to feature engineering, are the most important part in my opinion. Okay, so for step one, the preparing data leg of NLP processing. First, we'll do document or text cleaning, and then we'll do the pre-processing and feature engineering, right? So 2, 3, 4. Okay, so remember, Python is the main programming language used on data science or AI related tasks. Okay, so we have these packages that we could use. We have the natural language toolkit package. We have Spacey, TextBlob, GenSim, Scikit-learn, Pandas, regular expression, string, beautiful soup, Unicode data, lang detect, and contractions, right? So these are all different packages needed to help us in the pre-processing of our data, text data. Okay, it also helps us with feature engineering as well. So all those three layers there, we'll use these as a means of getting our feature vector, right up until step 4. Okay, so these are important packages to know.